Let's assume you have started building your project as a small monolithic application. Your single monolithic application is packaged as var archive and it is deployed into Tomcat servlet container and it works with a single MySQL database. Now, eventually the functionality of your application grew up, it became very large, and your team decided to split this large monolithic application into smaller microservices. When your application is split into multiple different microservices, each microservice will have its own database. It is called database per service design pattern. There is no more single database that contains all information about the product, users, and orders all in one database. The product's information will be in products database, users information will be in users database, and the orders information will be stored in orders database. The products microservice will store, edit, and search products in the products database. And other microservices like users microservice and orders microservice, they do not access information in the products database. If needed, microservices can be scaled up. For example, if the load on one microservice increases, you can run multiple instances of it on the same server. And this will be another microservices design pattern that is called multiple service instances per host. If needed, you can run multiple instances of products microservice on multiple different servers. You can start as many instances of products microservice as needed because each instance of products microservice starts up on its own port number and they do not conflict with each other even when they run on the same server. But this also brings a challenge. Let's say you have a client application that used to communicate with your single monolithic application via single port 80. It was possible because you had only one single application running on a single port number. But now you have split your application into multiple microservices. And to scale up products microservices, you have even started multiple instances of it, each running on its own port number. So how do we make our JavaScript application communicate with a destination microservice if they all run on unique random port number? We cannot be hard coding all of these port numbers in JavaScript application because if our microservice restarts, it will restart on a new port number. And the JavaScript application is not aware of that new port number. So what do? And the solution is to use API Gateway. API Gateway acts as a central point of entry for all HTTP requests that are sent to your application. It accepts HTTP requests and then it routes the request to a destination microservice. Our JavaScript application does not need to know the location of all microservices. It only needs to know the address of our API Gateway, and API Gateway will then route HTTP request to a destination microservice. But how does API Gateway know the location of each microservice if their port numbers random and dynamic? Every time when a new instance of a microservice starts up, it will start on a new port number. Do we hard code that new port number in API Gateway? And the answer is no. API Gateway will learn the location of each microservice from Eureka Discovery Service. And the Discovery Service is another design pattern that is used in microservices architecture. Microservices are configured to register their location with service discovery. When each microservice starts up, it registers its location like IP address and port number with Discovery Service. So the Discovery Service is like an address book of all currently running microservices, and API Gateway will learn the location of a destination microservice from Discovery Service. Now, it is possible that there are multiple instances of a microservice running, each on its own unique port number. For example, in this slide, I have multiple instances of products microservice running. So when API Gateway learns that there are multiple addresses of products microservice, which address will it use? Which instance of products microservice will API Gateway route HTTP requests to? If there are multiple instances of microservice running, then API Gateway will equally balance HTTP requests between these running instances. And if API Gateway that is being used does not have a built-in load balancer client, then there are load balancer applications that can be used with API Gateway to equally load balance HTTP requests between the running instances of a microservice. Now, the more the functionality of the application grows, the more of different microservices you will have. And each microservice will have an application properties file or application YAML file with different configuration settings. Managing all of these different configuration settings becomes very challenging in distributed microservices architecture. The solution to it is to use centralized configuration. All microservices, as well as Discovery Service application and API gateway, can all be configured to fetch configuration details from a centralized configuration server. And this solves a lot of challenges. First of all, configuration settings are centralized and can be managed in one location. Second, if a certain configuration settings changes, then it is possible to push a new value of that configuration property to a running microservice without actually taking that microservice down and starting it again. As you can see with microservices architecture, your application becomes truly distributed and scalable. Microservices can run on multiple different servers and they can be scaled up and down as needed. When needed, you can easily start up 5 more instances of a microservice, and if one instance goes down, then you will still have 4 instances running. And this is just an overview of a very simple microservices architecture. Applications can be much more complex, and there are many more design patterns out there to help us solve the challenges that we face in these complex distributed transactional microservices architectures. In previous slide, I have mentioned several design patterns. I have mentioned the database per service design pattern, the service discovery design pattern, API gateway, and centralized configuration. That there are many more that we can still come across, like for example, distributed tracing, circuit breaker, access token, event sourcing, CQRS, and many more if you research into microservices design patterns. It is easy to implement one single microservice, but it is not easy to implement an application with business logic distributed across many different distributed microservices. But microservices design patterns make it a lot easier for us. So if microservices is something that you will be doing a lot, then I suggest that you research into the available design patterns for microservices architecture and study them in greater details. And as we build a sample application in this video course, we will use many of these design patterns, but of course not all of them. So I'm encouraging you to do more research into it.